Because, yeah, we went over this. Jordan, you still need a copy of this, correct? Come and get it. Okay. So what is the extended ratio? Ooh, yikes. Looks like, oh, I got a couple people who got it right. Let's look at it. Bro, we've been in class for 13 minutes. You can't say I didn't give you time to finish. You chose not to do it. That's not right. So, what is the extended ratio of a 45, 45, 90 degree triangle? You should have out the task from yesterday right now, especially if you did not know this answer. Rin, I need you to put that away. I need you to get your math out. Okay, put that away so that you can focus on your math. Now, I will say this. Some of us are close with this idea of x squared plus x squared. But remember, a squared plus b squared is equal to c squared, right? It would be x squared to 2 squared, which means that the first side of that 45, 45, 90 degree triangle is how long?
X.
If it's x squared, how long is the side?
X squared.
Side is?
That's it.
I think I heard someone say it. If it's x squared, the side is?
X.
No, x.
You just said it. Before you just jump to x squared because I said the word x squared. It's x. Remember, the Pythagorean theorem is a squared plus b squared equals c squared, right?
Yep.
So what is being squared? Just the x. So that length is x. What is this length? X? No.
Oh no, that's x squared root.
Look at the table. Yo, I see one person right here with their task out. I see one person with it here. Ari, where's yours? We need our special right triangles task out. Come on. So there it is. So look at the top table on the back side. When the side length was x, what was the hypotenuse or the diagonal? Why are you looking at me? Look at the table. X times the square root of 2. When the side length was x, then the hypotenuse was x square root of 2. Because the ratio, and I will point this out, how do we write ratios? Because I know some people are doing dashes, and I see something else a little bit different here. Huh? We can do a colon. You can do it with a fraction. Remember, we've done scaled factors, which are ratios with a fraction bar, right? But when we have 3 values, this is how we write a ratio. That is known as the extended ratio of the 45, 45, 90. That should be at the bottom for number 6 on your page. Because we should have already written that yesterday, right? You already had it? Okay, this is not brand new information. So that means when I look here at this question, what is the length of the hypotenuse of the triangle? If the triangle is a 45, 45, 90? I mean, yeah, you could go through all the work of doing 13 squared plus, how long would this leg be? 13. But if you know the ratio would be 13 times the square root of. This is why it's important and useful to know those special right triangle ratios. Because that's all I have to do. Now, I will point this out. To go from the side length to the hypotenuse, I had to multiply by what?
2.
3.
To go from 13 to that, I multiplied by 2?
1.
Okay, I want to point this out. You see that 13 right there?
Yeah.
You see that 13 right there?
Yeah.
What did I have to multiply by?
1.
That's not a 2.
What?
13.
Say it again, Kelsey. The square root of 2. 13 times 2 is 26. This is not 26. This is 13 square root of 2. To go from the side to the hypotenuse, I had to multiply by the square root of 2. That's important to notice. So let's say I have another 45, 45, 90. Let's say that this right here is 30. That's the hypotenuse. Now to go from the hypotenuse to the side, what would I have to do? Thought I heard someone over here start to say it. Say it again, Josh. Closer. Divide by the square root of 2. Right? To go from the side to the hypotenuse, I multiply by the square root of 2. So to go backwards, I'm going to
Go forward.
divide by, and you can just leave it like that. You don't have to make it more complicated than that. Older generations of teachers would require you to do this thing called rationalizing and yada yada yada. I don't care about that. I care that you recognize that I would divide by the square root of 2. That's it. So if you know your ratios, it makes it really easy. You can also use trig ratios here to solve this equation. And we'll talk about how in a little bit. But let's look at the next part of this task. So we are moving past the 45, 45, 90. Hold on one second. To get into the 30, 60, 90. So I want you to notice, remember, and this is where some of us got to is in the bell ringer, we want to use the Pythagorean theorem to determine the extended ratios of the 45, 45, 90 degree triangles and the 30, 60, 90 degree triangles, which those are the special right triangles. And then we're going to use those extended ratios to solve special right triangles and to figure out the trig ratios. So we already did the 45, 45, 90 yesterday using the Pythagorean theorem. We filled out this table. We generated, we found the general ratio, right? X square root of 2, or x square root of 2. So now we are moving on to a new set of triangles. What's the angle measure of these triangles? Yes, you do. Look at the sheet of paper. You okay?
69.
D.
Oh,
No.
I was just reading the
Come on, what's the rate? What are the angles in this one?
30.
30, 60, 90. Thank you, right? Now, I need you to pay attention to where we're getting this 30, 60, 90 because, just make sure your name's on both sheets, don't staple it.
Yeah.
Okay. So, please hear me very clearly on this, alright? We need to know where the 30, 60, 90 is coming from. How did we get the 45, 45, 90? Notice we didn't just start with 45, 45, 90. We started with what shape? A square, right? And we split that square in half. We drew the diagonal to split the square in half to make sense out of the 45, 45, 90. Well, now we're going to take an equilateral triangle. It's been a minute since we've talked about this. What do you already know about equilateral triangles? So remember, congruency would be like between different shapes. Now they do have something that's congruent.
Similar.
I heard someone over here say it. The side lengths. If it's equilateral, what does that prefix equa make you think of? Equal or equivalent or the same, right? And lateral is referring to sides. So they have the same side lengths. Notice, if you look right here, how long is this side? That's 2, isn't it? Well, see, in between those dots, we're going to call that how long? 1. In between those 2 dots is going to be?
2.
No. Sorry. No. In between these 2 dots, just where my fingers are, that's 1. So 1 plus 1 is? 2. Right? How long is it along the base here? 2. How long along this side? 3. Okay? So we started with an equilateral triangle. And this is a term that we haven't used yet because we didn't get to this concept. But this word altitude, all that means, actually, has anyone ever heard the term altitude before?
Yes.
Planes.
Planes, right? What is that referring to in a plane?
Going up.
How high you are. Well, height is always measured. Actually, let's look at it this way. Let's say I have Oh man, I don't draw planes. I'm just gonna do. Here's my plane. Yeah.
Airplane?
That's my plane. Okay. So would I measure? Let's say this is my ground. Would I measure the height to here?
No.
Why not?
Because
It's going back.
That's inaccurate.
But why is that inaccurate? I mean, there's a distance there to the ground, isn't it?
It's further.
I mean, I guess.
Say it again, Austin. It's got to go straight down, meaning it needs to be what to the ground?
Oh, we hit it.
Perpendicular.
I heard someone over here say it.
Perpendicular.
Perpendicular. The altitude has to be perpendicular to the ground. Well, guess what? This altitude has to be perpendicular to the
Bottom.
base, is what we would call it, right? So, when we talk about altitude, what we're talking about is a segment from one vertex that is perpendicular to the opposite side. So to have an altitude, it has to be perpendicular. And notice I just used this symbol for perpendicular here. A segment from an altitude is just a segment from one vertex that is perpendicular to the opposite side. Okay? Now, this is not part of the 30, 60, 90, but to give you a little bit better understanding of it. So if I have this triangle, it's not the best one. I will point this out. If I start from this vertex, that would be about perpendicular. That would be an altitude. We all good with that idea?
Yes.
Okay? But I will point this out. That is not the only altitude of this triangle. I can also have an altitude from this vertex. It's not... No, that's not even close to perfect. Maybe here. Does that look almost perpendicular? No. How about that?
No.
That's not close to perpendicular? I would think that's close. I don't know. It's definitely closer than the other one. Let's find out. I'll tell you what, that is 89 degrees. That's pretty close to perpendicular. Okay? So I want you to notice, is there only one altitude? No. And altitude comes from either any of the vertices. So how many altitudes can there be for one triangle?
2, 3.
Why 3?
5. There's 3 sides.
There's 3 sides, and remember it starts at a... How many vertices are there? 3, right? So there are 3 vertices, so you can have 3 altitudes of a triangle. But we're specifically looking at this altitude right here. Now, we already said an equilateral triangle has congruent sides, meaning all the sides are the same. Does anyone know anything about the angles of an equilateral triangle, though?
Oh dear.
They be the same. It's important to recognize that equilateral triangles are also, what would we say if all the angles are the same?
Congruent? Oh.
Huh?
Equivalent?
Equilateral.
I thought equilateral was for the sides. You just said that all the angles are the same too, right? So,
Equivalent. E.
y'all never hear this term before?
Equilateral. What that say?
What's the word?
Irregular.
Equiangular.
Oh,
Okay, y'all have heard equilateral, right?
yes.
Okay, you should have learned equiangular at the same time. What do you think equa means? Equal or the same, and I will say it's closer to equivalent. Equivalent what? Angles. Equilateral triangles are also equiangular, meaning that all the angles are the same. Bros, aren't you supposed to be taking a test? You're completely done? Dee Dee, you done as well?
Yes.
Okay, put it up here on this desk where the projector is. Okay? So, equilateral also means equiangular, or equilateral triangles are also equiangular. So what are the measures of the angles for an equiangular triangle? Say again? 60? If I have 60 here, and 60 here, and this is also 60, how many degrees is that? 180? So does that work?
Yes.
So, equilateral triangles are also equiangular. Each angle is 60 degrees. Okay. Now, we can actually finally get started into this because we have an altitude. What's that altitude going to do to the 60-degree angle?
Chop it in half.
It's going to chop it in half, just like we split that 90-degree angle in the square into 45 and 45, right? So what's half of 60?
30.
So there's 30 degrees. And what's this angle? 60. Remember, over on this half is 30. And then what's this angle measured down here?
60.
90. So what kind of triangle do I have? 30, 60, 90. Notice, Matthew, you said equilateral? Is that what you said? Equiangular. Remember, it was equiangular, but we split it in half, right? When we split that 30, 60, 90 in half, or the equiangular triangle in half, we end up with a 30, 60, 90 degree triangle. Now, we can do this to find the extended ratio, or use the Pythagorean theorem to find the extended ratio. So I want you to notice the sides have been labeled by its unit length for this example. Use Pythagorean theorem to find the length of the altitude of the equilateral triangle. Notice, how long is this length here? How long is it? 2. That's already on your sheet, right? Notice this side down here was 2. Now it's 1. Why?
Because it's split.
Because it's split in half. So this is 1 and this is 1.
Oh.
And notice we have a right triangle right here.
Right.
So what can I use to find this missing length of the altitude? The thing. What's the thing? Pythagorean theorem. Let's work within our small groups for just a few minutes to try to... Huh?
I ain't got the paper.
Were you not here yesterday? No, you weren't. Okay, let's work within our small groups. Let's work with our small groups to try to figure out what that altitude is. It shouldn't take us too long. We'll come back together in a little bit, which means I need you to persevere for the next, let's say, 4 minutes. Hopefully it won't even take that long. Work within your groups. Figure out what the altitude would be. Use that Pythagorean theorem. Maybe write the equation for the Pythagorean theorem before you get started. Anton, you done?
So I don't even know where we come from. I ain't even count.
Why you do that?
How many pages it is?
2?
4.
I need us to focus on the 30, 60, 90.
I can't
Remember,
count
what do
myself.
There's short ones up there.
I just dropped it down.
It's green. Okay, the next closest.
Hey, let's get him. Can I get Terrence? Because I've been there like for a week.
I'll take care of it. You worry about you.
Bruh, smooth this.
Y'all. I need you to understand, multiple people are already getting to work on this. Y'all need to at least attempt to use a Pythagorean theorem here. Let's get to work. I'll help you if you get stuck. Yeah, but that one is labeled as 90. No, I didn't label it. Because you don't put the little square symbol to indicate that it's 90? Yeah, that's 90. Because remember, you see how remember what we said about the altitude? It's what to face perpendicular, which means
Well, he
this
knows
side
he
is
kills
90.
him.
So we're just going to focus on this triangle over here. Okay. Let's use. Well, they're the same.
You was like he did.
1 squared plus b
But
squared
he
is 2
did.
squared.
Wrong.
You just solve for b now.
Come on, your daddy been there.
So you have 1 plus b squared equals 4. Once you did the 1 squared plus b squared equals 2 squared, you're trying to solve for b. So what do you need to get rid of? Could you subtract 1?
Yeah, that mean that
Will that
nigga ain't
get you
even
closer
have
to knowing
much.
what b is?
The nigga ain't
B
like
squared is equal to 3.
stupid ass what?
Y'all got here asses on here. Smoke them here.
Why
You finna smoke what game?
Roll it up. Go up a little, up and roll this shit up.
Okay, but what is c? The hypotenuse, right? Why do you say You don't know this. You did 1 square. You don't know the altitude. Yeah, you don't know that. Yeah, you don't know that. How's it going over here?
I'm trying to figure out what the Pythagorean theorem is.
Bro, there's no like figure it out. You should have figured that out in middle school. We've used it multiple times this year. Yeah, you did Pythagorean theorem in middle school.
Not the teacher I had, I promise. No.
Okay, you've done it multiple times in my class already this year when we did the distance formula. So, can someone remind us of what the Pythagorean theorem is? Oh, so you knew what the Pythagorean theorem was. You didn't need to figure out what it was. You need to figure out how to use it, maybe. Does anyone know what A could be? Why 2? It's not just any old side. But remember, what is C?
What it equal to?
Not just what it equals to. C is our hypotenuse. C is always the hypotenuse. It has to be the hypotenuse. So what is our hypotenuse in that triangle? 2. Oh, so the 2 needs to go here, doesn't it?
Yes.
What could I plug in for 1? For A?
A is 1.
A is 1. And do we know what B squared is?
1.
Look again. Is that a 1? Do we have the length of the altitude?
Yeah.
So it needs to be A, B. How'd it go over here? That value? Go ahead and try to work on number 9. We'll talk about it a little bit. Did you not figure out that? He was right. He was just like, okay, with this one.
Take our ratio.
Something's wrong with this.
I'm smoking up there.
Put your granddad.
Look your granddaddy, you're a champ.
That nigga gonna cry.
Thank you. Thank you. Thank you. All right. So I saw a lot of us getting started on this and actually doing very well. I was very proud of those of us who got started. And some of us made mistakes, and that's okay. First things first, I would always write out what the Pythagorean theorem is. What is it? Okay. So a squared plus b squared is in fact equal to c squared. The only side that we need to be careful about is which one? The hypotenuse, because which letter is the hypotenuse?
C. 2.
Now be careful. C, right? We are squaring the hypotenuse, but the hypotenuse is just C. Yes, Ren?
Oh, I was just stretching.
Oh, you're just stretching, okay. So what is going to take the place of this C here?
2.
What's going to take the place of C?
2.
2 squared. Now, I want to ask this really quickly, because this is actually a thing to think about, okay? Where did most of us substitute the 1 in? For A or for B?
A.
For A. And that's fine. It leaves one side unknown, but I will remind you, what are we trying to calculate? What is this length called? An altitude? Hey, what would be a good letter for an altitude? That's,
you don't. Base and then.
yeah, A for altitude, B for base, and then C is just the hypotenuse. That one doesn't make as much sense. But an altitude and a base, that's where A and B are probably coming from. But can you leave the variables in B? Wow. Yikes. I feel bad for everyone back there. Y'all, eyes up here. It's time to focus on math. Rose, you need to worry about your education, not talking across the room. Because you were directly talking across the room. Other people were laughing, but you're talking across my room. Okay. You worry about your education. We'll figure it out. Okay. So, can you smell it?
Yes.
Is that bad? That's far away. All right. Hey, stop and listen. Kaylin, can you open the door, please? Oh, it's already open. All right. I need everyone's attention. Stop and focus. Hopefully we got the giggles out of our system. Hopefully the smell's going away soon. But that means, what am I going to substitute in for B here?
Base. Or, yeah, base.
Well, what is the base? 1. Notice, I can do it either way, right? Either way is fine. And I think most of us already did this, so I'm going to go ahead and go. A squared plus 1 is equal to 4. Now what would I do to solve this equation?
You would do, minus 1.
Sorry, I totally forgot to split group 7 up. Let's see. Brandon's doing a great job of working, so I'm going to leave him where he is. Josh, can you come up here to group 1? And Austin, can you go over to group, what is that in the back? 6. Thank you, gentlemen. Okay. Set right there. Hey, Dee Dee. It's to help us figure out the triangles. Okay, so Kyson, why would we subtract 1 right here?
Wait, where we at?
A squared plus 1 equals 4, so we subtracted 1. Because that's what Matthew told me to do.
Yeah.
To get something by itself.
Okay, but why would that get something by itself? Because it's the what, Kelsey?
You don't know.
It's the inverse. You talked about it in middle school, and we've talked about it in this class since the beginning of the semester.
Right.
We're adding. So we subtract. What is 1 minus 1? 0. Why do I have to subtract it from the other side? Not equal, equivalent, right? We're going to get a different equation, but is it going to still be effectively the same? Y'all, get the giggles out of your system. You got 2 more days of learning with me. That's it. And we got a test on Tuesday, review on Wednesday, and y'all got an exam on Thursday. Focus. So what do I need to do to finish solving for A? Square root. And so, the square root cancels out the square. A is equal to 3. Not 3. Why y'all let me do dumb things?
I don't know.
The square root of 3. A is equal to the square root of 3. So we got a 1, a square root of 3, and a 2. A 1, a square root of 3, and a 2. Well, if you know that it's a 30, 60, 90, you can still use trig ratios to find the other sides. So So, Matthew, you worry about your own education, man. You don't need to butt in. It's not cute, it's not funny. You're just gonna piss people off. Stop it.
Boy, shut up, that's why you in bed.
Y'all mama be saying.
I know you said worse. I know you hear worse. Don't even play like the word piss is that offensive.
I don't say bad words, that's bad.
Dee Dee, I called you out for saying bad words.
That's bad words.
Yes, bad words. Okay, so
What are bad words?
I'm going to work through number 9 with y'all.
Okay.
And I'm going to have y'all do number 10 on your own. So I want y'all to notice we're still using the equilateral triangle that is 4 units on the sides. And the sides have been labeled. And we're going to use the Pythagorean theorem to find the length of the altitude. So, does anyone know what this angle measure right here is, by the way?
Where?
Looking at number 9. This one right here is 30. Y'all agree?
I don't. No.
What do you think it is? 60. Remember, that's one of the angles for the equiangular triangle. Where would the 30 be? At the top, because that 60 got split in half, right? So here's 30. And here is 90. Okay? So, how am I going to find this altitude? Nobody? No one knows how to find the altitude?
No.
Oh.
Thank you. Remember, they kind of gave you that in the directions. And Kyson, it helps pick up a pencil and write instead of doing whatever you're doing.
I'm letting her get number 7.
So, Ren, what's going to get substituted, or give me one of the values to substitute into that equation? Do you know A, B, or C? You know that it's on your sheet of paper. You don't have to stare at the board. I'm going to come back to you. I'm going to get someone else to give us one. You have to give us the other. Claire, can you give us one of the sides to substitute into that triangle? C is going to be 4. Why is C 4? Okay, C is my hypotenuse, so 4 is going to get substituted in for C. Cool. Ren, do you know what another value is I can plug into that equation? Say again. 3? Where are you getting a 3 from? Look at the triangle. The only other side length is what? We're on number 9. Not number 10. 2 is going to get substituted in for what? Does it matter which one?
No.
No. I would plug it in for B because it's a part of the what? Base, right? That's just me. Hey, Gabe, I'm teaching, aren't I?
Yes, you are.
Is it easy to use both your ears to hear what I'm saying while you're using your mouth?
No.
No.
What number are you on?
Number 9.
Well, which the problem is for number 9?
This is number 9.
Okay.
Okay? So A squared plus